So this is the second kind of faculty development seminar on statistics, and today we're going to kind of move away from this idea of evidence-based guidelines and so forth and kind of get into the meat and potatoes of statistics, and we're going to talk about t-test. Next week it's going to be kind of ANOVAs, and then we're going to get into, for the final week, correlation and regression, which may be statistics that you or some of your people will end up doing. And I actually have a problem. If you look at the agenda there, let's say, and I used to do talks on Alzheimer's disease, want to do a new study on patients with Alzheimer's disease and memory. I take 3 people with Alzheimer's disease, put them on a new drug, and test their memory for 10 words. I show them 10 words one at a time and test their recall, and for the group that gets the new drug, they recall 5, 6, and 7 words, and I do the same thing for 3 people without the drug. They recall 1, 2, and 3 words. Now, would I ever do a study with 6 people? No, but if I'm teaching people about statistics, would I do that? Sure, why not? Because it just makes it a little easier to understand. And the concept is the important thing, not the amount of numbers. So are people familiar with a z-test? The first question I have for you here is, would it be appropriate to run a z-test on this data set? A z-test versus what we're going to talk about today, which is a t-test. Do you guys know the difference between, and if you want to take notes, you're certainly more than welcome to, the difference between, have you guys come across in the literature a lot of z-tests being run? Does anybody know why? That is often the case. To do a z-test, to get to the point, you need to know information about the population. You need to know the mean of the population and the standard deviation. If you're doing things on IQ, if you're doing things on some intelligence measures or some other things where you know population-based information, a z-test is highly appropriate. But when we in healthcare, psychology, OT, PT, PA, when we do our experiments, do we usually know anything about the population? No, we just know we want to understand the population better. But in this particular case, am I giving you any information about the population?
Just that they had Alzheimer's.
Just that they had Alzheimer's disease. There could be some population-based information on that depending on the severity of the disease state, but generally I'm giving you nothing, and I'm saying we got this group, they got this, that group, they got that, and so the appropriate statistic to use on that would be
T-test.
Yeah, named after me, Stuart Allen Tausman, the t-test. No, I'm sorry, I made that joke last week. The SAT exam, Stuart Allen Tausman.
Nice.
There you go. Yeah, isn't that special?
Well played.
There was somebody at Jefferson College whose initials were SAT as well, so we used to go around and SAT squared, as it would be. But you don't have to know that. I was going to say for the test, but we're not doing a test here. So a t-test is appropriate when you know nothing about the population. And there are a few different types of t-tests that you might be familiar with. Does anybody in the group know what kind of t-tests we often work with? I'm seeing a head nod over here. You want to share?
I'm thinking one-tailed or two-tailed.
So they could be one-tailed or two-tailed. One-tailed is where you kind of have more of a chance of having hits, but maybe false alarm. Two-tailed is further away, harder to reject the null hypothesis. But these are different types of designs, I should say, different types of designs where you could run a t-test. So when you set up an experiment, there are some different types of designs you could use to do t-tests. Let's say, for the sake of example, I take you people over there and I run you on something, and I take these people over here and I run them on something. Versus, let's say I take everybody in the class and I run them before and after I do something.
Pre-test, post-test.
So that would be a pre-test, post-test. So one of the types of designs is called a within-subject design. Now, statisticians get hung up on language. Within-subject design, paired t-test design, related sample design, they all basically mean the same thing. So we have within-subject designs, and there are 2 types of within-subject design. When I just mentioned this idea of measuring people before and after, do you basically measure the same thing at both points? I call that a within subject intervention design. Intervention design. Because you're measuring the same thing before and after, you're just doing what? Something in between to help improve people on whatever OTs, PTs, psychologists want to do. So that's called a within subject intervention design. Is that design kind of popular?
Mm-hmm.
Yeah, it's very popular. The other type, and it's not used so much in the health sciences, but in psychology it's often used. You use a within subject design where you test people basically more than once in two conditions. You might want to test memory when it's visual or when it's acoustic. And if you measure people, let's say you had 10 people and you wanted to give them 10 words acoustically and then 10 other words visually, that wouldn't be an intervention design because you're testing them in two separate conditions. When you do that, would it be a good idea if you took all 10 people and gave them all the visual first and then the acoustic second? Would that be a good idea to choose if it's a non-intervention, a within subject design? So you have a visual list of 10 words and you also have another acoustic list. Would it be good to take the 10 people and say, I think people are going to be better at visual. I'm going to give them the visual list first, and then you give them the second list that's acoustic.
Are they the same words?
Different words. Why would you say no?
Whether they remember what they saw first or what they saw second.
They might remember what they saw first. You would test recall after each trial. But the problem that you would run into is potentially when they're given the second trial, recall, what might just happen to recall?
That happened.
It might go down. What we do in those situations, have you heard of the word before, counterbalance? When you're doing a within subjects non-intervention design, many times we counterbalance. You give half the people the visual first and half the people the acoustics first. So you can rule out any carryover effect. Does that same principle apply to the intervention design? Does it apply to the intervention design? Do you have to? No, you're all looking at me like I'm on drugs, and I am on drugs, but I have asthma, so I have to be. But no, in an intervention design, it's before and after. You don't counterbalance and do after before. That just doesn't make sense. But both of those types of designs are within subject designs. I just call one an intervention type, and the other one is non-intervention type. But this situation, the Alzheimer's situation, does that fit either one of the two scenarios I've just described? Is that a within subject intervention or non-intervention design? I'm seeing some head shaking here. It does not, does it? Because how many times are we testing people? One, singular sensation. Remember that, 42nd Street? Anybody? Okay, that was a Broadway show a long time ago. I tell these jokes in my classes and the students look at me like, but I always have one that's like, I gotcha. That was a hit Broadway show. So anyway, in this situation, if you're testing people only one time, that is considered an independent sample design. An independent sample design. So there are really three types of t-test designs. There's the independent sample design. That's what this is. You're just testing people once. There's the within subject designs. We have two types. Most popular in your disciplines might be the intervention type. And then we have non-interventions where you test people in two conditions. And we said, what should you do if you ever do two different conditions with the same people? Counterbalance.
All right, can you say those off again? Independent sample.
Independent sample, and then in the within subject sample, you have intervention and non-intervention design. And the intervention and non-intervention within subject, they both use the same statistic, but they're slightly different in design, because when you're testing people in auditory and visual, You're actually testing them in both conditions. In the intervention, you're not. You're testing before, you're doing it, and then you're testing after. So the design is just a little different. So we need a formula to use. We need a t-test formula to use. So if you were to look at the data there, does it look like we should be happy with our Alzheimer's drug? When you just look at
Yeah.
Roman numeral 1, why would you say yes?
They remember more words.
They remembered more words. What measure of central tendency would you tend to look at to make the statement it looks like they remembered more words? What's the most frequent measure of central tendency? Say again?
Average.
The average, the mean. The mean for the first group when they took the product was what?
6.
6. For the group that didn't get the product, the mean was
2.
2. That is known as the treatment effect. That is known as the treatment effect. Do you want that treatment effect to be large or small if you're the drug company? Large.
Depends on if that's what you want.
Yeah, it depends on if that's what you want. But usually drug companies, when they give their drug, they want wonderful things to happen and the world to be solved and everything to be a better place. And sometimes it works out just the opposite. Actually, I can give you an example since you brought it up. Many years ago, for Alzheimer's disease, there was a thought that estrogen might be somewhat neuroprotective for Alzheimer's disease. So they set up a huge government study, the Women's Health Initiative, and they gave a bunch of women estrogen treatment. And guess what happened?
It works.
Not only did it not work, guess what they had to do to the study?
Stop it.
They had to stop it because guess what was going on? It was destroying memory. So they got significant results that were kind of unethical, if you will, and so they had to pull the plug on that study. That happens actually a lot with Alzheimer's. Well, they have to stop studies a lot with Alzheimer's disease because they have all sorts of things going on and they're just stopped in their footsteps. Do people know about Alzheimer's disease a little bit? I can give you a little more background. There are actually 29 research centers around the country doing research on Alzheimer's disease sponsored by the federal government. And they've got a lot of good things done. They get to phase 1 and 2 of clinical trials, and sometimes these things look really good, but then they fail. If you know anything about Alzheimer's disease, the biggest problem we have with Alzheimer's disease is we have this amyloid precursor protein, and it gets cut by a beta peptide, and then that turns into neurotoxic stuff in the brain, and that causes Alzheimer's disease. So if you were a drug company, what would you want to do?
Keep that together.
You would want to take, we all have amyloid precursor protein, but what would you want to stop? The plaques by blocking the beta peptide. Merck went through clinical trials 1 and 2. Drug looked good. They got to phase 3 and didn't work out. And so we see that a lot with Alzheimer's disease. But this is, let's go back to the statistical example at hand here. So we have the product. It looks like it works pretty well. We have in number 2 the t-test formula. Now the numerator for that, mx minus my. What do you think that stands for?
Difference in the mean.
Well, you wouldn't want to say the pre-post here because it's not an intervention design, right? 3 people got it, 3 people didn't. Those represent what?
Mean of the group.
The mean of group 1 and 2. How do you want that number to be?
Big.
Large. That reflects the treatment. You want the treatment usually when you do something in OT, PT, PA, nursing, whatever you have. You want the treatment to be large. Is it pretty easy to compute that numerator?
Mm-hmm.
Yeah, what is the numerator?
4.
It's 4. Well, that was easy. Now we get to the denominator part of the equation. How does that look?
Not so complicated.
That doesn't look so easy.
Take a key.
Yep.
So the denominator looks like a pita. Did we explain what a pita was last week?
Pain in the.
Pain in the, a pain in the gluteus maximus. A pita. So we wouldn't want to have to compute that by hand. That would be a PETA. That would be a real pain to do. The denominator, always with the t-test though, the numerator reflects treatment effect. The denominator always reflects error. That denominator reflects error, and there are statistical reasons why that is the denominator, but they're not relevant to what you need to know here. How do you want error to be?
Small.
You want the error to be small. So the important thing with the denominator is you want the error to be small. Now I actually went and put some of these numbers into SPSS, and I was actually able to get the answer for that, because I would never do this by hand. Do I give you what the denominator is here?
Is that the 0.816?
There you go. You can use 0.82 if you want. So how would you get your t-test score? What would you do to get your t-test score? What would be the math involved?
Add the bottom into the top.
There you go. So you take 4 and divide 4 over
Right?
0.816. You divide that out, and what did you get?
I have no technology.
I have no technology. Okay.
6 something.
6 something? No, I don't think so.
No, 4 over.
4 over 0.81.
Sorry, 4.9.
01960.
4.9 is the correct answer. Thank you. Oh, I turned my phone off.
Got burned out crew.
4.9. Thank you. Shout out to the burned out group, because they just keep working so hard that they burn themselves out. I hope they didn't.
Do it all around here.
So 4.9. So when you do hypothesis testing, you get a t obtained value of 4.9. What would you tend to do with that?
Email you.
You might email me,
I
but
think we probably look it up in the book for.
yeah, you would look it up in the book, and I've already taken the liberty of doing that for you. You would compare it to a critical score. How many degrees of freedom do we have in this situation? Does anybody know?
2.
Why would?
Guessing. I'm totally guessing.
Okay, you're totally guessing, so you want an alibi for your 2. Your answer of 2, how did you come up with 2?
Because if we only have one number on each side of the mean for each of the groups, then maybe I only have degree of freedom of 2. I don't know.
That could be the logic, but it isn't necessarily the logic here. How many people do you have in the first group?
3.
So how many degrees of freedom there?
3.
I like his answer better. 2. Don't worry, the last class I taught for the psych students, I was accused of being non-directive on my answers. So you have 2 degrees of freedom in group 1. How many degrees of freedom in group 2?
Same.
2. So how many degrees of freedom do you have here?
4.
4. So you could look up on a table and a chart the degrees of freedom, but you have 4 degrees of freedom here, because you have 3 in each group. It's basically a number in the group minus 1, and you add them up. And you would get a critical score, and the critical score in this case in a table, but we don't really like to use tables anymore. That was kind of old school. The critical score is 2.5. The critical score. So the T critical score is 2.5. What was your T obtained score?
4.9.
4.9. Is this a happy or sad day in this room? Or a happy or sad day for the drug company? Your T score is greater, your T obtained is greater than the critical score. Would you be happy or sad? You would be happy. Sorry, I'm getting into my psychology mode there, right? Happy, sad, mood states. You would be happy if your obtained score is greater than the critical score. You are statistically significant. And so in this situation, you would be statistically significant that the people who got the drug performed statistically better than those that did not. How would you write out the T statement? Does anybody know? Do you know how you would write that out in APA form? I kind of give it to you in number 7 there. You write the letter T. How many degrees of freedom did we say we had here?
4.
4. Equals, what was our T obtained?
4.9.
4.9, comma, would it be P greater than 0.5 or P less than 0.5?
Less than.
Less than, because you're significant. If it's significant, P less than 0.05. Real world statement?
Looks good. Looks effective.
It looks like the drug helps. Say again?
We're 95% sure it's right.
No, you wouldn't want to do the 95%. That'll be on the second page of the handout,
Okay.
but that's still a reasonable answer. You would want to say it looks like the drug improved memory. So it looks good. Go ahead.
So why would you want to merely compare the t-value to the critical score rather than, I guess, like actually calculating the p-value? Like, 'cause did we talk about the?
Yeah, we did, and we're doing this for the sake of example here,
Yeah.
but what we will do, and maybe we'll even do it next year, is we do this with SPSS, and then it'll tell us the exact probability.
Okay.
But in the old ways, when we didn't have computers and calculators to do this, we got the score, we computed it, we compared it to a book
So
value.
it was just a tipping point of.
Yeah,
Greater or less than.
greater or less than 0.5, but now we can do it in a different way than that. And actually, maybe we'll move to that next. Any other comments or questions about this?